So now that we have looked at what sets the stage for the fruition, the maturation, let's look now at what really unfolded afterwards. So to keep things on track, we focused on period 1, 2, and 3, and in green I have highlighted the vine physiological indices that have a direct impact on fruit composition, such as shoot elongation rate, nitrogen uptake, and vine water deficit. But it will be too simple if we overlook the contribution of light. And light effect on shaping fruit composition starts to kick in at bloom and keeps going at least until we reach the peak of coloration in the fruit. So that's what I symbolize here with the blue label. At the same time we are looking at the medical aspect of the plant, we need also to look at the interaction that the plant is going to have with environmental parameters. And that's still looking at the pre-veraison period. If we look at the post-veraison period, we can slice this period into two subparts. The first part looks at everything involving primary metabolites, such as sugar, acid degradation, and that slows down around 1250, 1300 growing degree days. Typically, if you track sugar per berry, not bricks, but sugar per berry, you see that there is a very rapid uploading of sugar into the berries that slows down markedly around 1300 growing degree days, and that's set up the start of the polishing of the secondary metabolites. The end of color accumulation is either happening at the same time sugar loading stops or right after. So this is why I have put those two arrows. And during that time, what keeps playing a critical role is light exposure, and of course, the lack of water under the form of vapor pressure, so that's what I mean by vapor pressure deficit, alongside with maximum temperature, will affect the turgidity of the fruit, its aroma profile, and degradation of color. So let's keep all of that in mind, and what picture can we draw of the 2016 vintage? Well, since light is so important, and the next speaker will actually share his knowledge on that, let's look at light regime. So what we did here was looking at the critical period from 600 growing degree days around the time of set up until 1300 growing degree days around the time when the color accumulation process is finished or about to finish, and look at how much light is actually coming from the sky. And we looked at the accumulated value. What you can see is that even if it has been slightly ignored, there is a variability vintages to vintage. You see 2012 with a lot of cloudless days being very high. You see 2015 being very low. Remember the wildfires. They did actually increase the scattering of light due to so many particles, and that actually markedly declined the amount of cumulated global radiation, so really the amount of photons. Here we've cumulated them and expressed them in kilowatts per square meter. So you can see that from a purely light consideration standpoint, 2011 and 2016 are fairly high, and on a similar regime, 2012 is a little bit above. So in that context, it's a good news, because that's the fourth, actually the fifth take-home message. Sure, we were on a slightly bitter note because nitrogen supply is high, water supply is high in 2016, crop load is relatively high compared to 2014, even if it's not exuberant. But all of those elements predicts that accumulation rate of anthocyanin should decrease. However, we are blessed by a high light supply, which actually may counteract those relatively negative effects of the seasonal traits. Higher light exposure increases flavonoids and polymeric anthocyanin accumulation. That's well documented. And if we bounce back off what Professor Kennedy last year shared with us, as more pigments, colors are incorporated into the tannins, it affects the physical property, hence the sensorial property of the tannins, by, in particular, reducing their activity. So the way protein of your saliva interact with the bound tannins. So that's good news. actually, in order to really hammering that, I thought it was relevant to share some data from our colleagues in Chile. Here I report the work from Matus in 2009, did a very interesting work on Cabernet Sauvignon maturation, and at the genetic level and at the chemical level, how light exposure was modulating the processes leading to fruit maturation at the skin level. And to keep things simple, just looking at a subset of his results, shaded versus non-shaded. At Veraison, clusters were actually opened to light. Then, destructively, they analyzed using HPLC technique different profiles to look at color accumulation. And you see that when the negative effect of temperature are sorted out, because they looked at the fruit looking on the east facing side of the row, so looking at the morning sun, light exposed boosts color accumulation. And significantly, it's a difference of 1,000 milligrams per kilograms of berry skin. Okay, so light is good, we get the picture. Actually, it peaks and slightly declines. So the shape of the decline post-peak, I'm looking at the decline here after week 5 post-Veraison, is site-specific. And we'll discuss what practices and what specificities of the site may drop the decline very fast or actually lead an absence of decline. So the conclusion before I introduce our next speaker is really enhancing and highlighting the role played by light in the time profile of total anthocyanin accumulation. Light exposure increases flavonoid synthesis, yes, but high temperature reduces anthocyanin. We also discussed that with the results of Mori in 2007 during the last vintage report last year. So it's my pleasure to introduce